LangGraph's state-driven orchestration mechanism enables dynamic agent routing through shared state communication, where nodes operate as state transformation functions within a StateGraph. This pattern allows for flexible control flow by tracking the last active agent and conditionally directing execution paths. We're about to examine how a swarm state graph initializes with two agent nodes, implements an active agent router to manage transitions, and compiles into an executable workflow. The configuration will demonstrate state-based routing between agents while maintaining a default starting point.
From LangGraph, swarm import add active agent router. Workflow equals StateGraph swarm state. Add node Alice, call Alice destinations equals Bob. Add node Bob, call Bob destinations equals Alice. Hash this is the router that enables us to keep track of the last active agent. Workflow equals add active agent router. Builder equals workflow. Route to equals Alice, Bob. Default active agent equals Alice. Hash compile the workflow. App equals workflow compile.
This code demonstrates dynamic agent routing in a multi-agent swarm using LangGraph's StateGraph. The pattern creates a bidirectional workflow between two agents, Alice and Bob, where each agent's output routes to the other. The key innovation is the Add Active Agent Router utility, which tracks the last active agent and enables intelligent transition management. The implementation builds a state graph with swarm state as the shared state schema. Two nodes are added. Alice routes exclusively to Bob, and Bob routes exclusively to Alice, creating a closed loop. The router is then injected with Add Active Agent Router, specifying both agents as valid routes and setting Alice as the default starting point. This router pattern allows the system to maintain context about which agent was last active, crucial for stateful conversations. The approach provides flexibility in agent orchestration while maintaining simplicity. By compiling the graph into a compiled state graph, the workflow becomes executable with standard runnable interface methods. The trade-off here is between explicit routing control and potential complexity in larger swarms, though the pattern scales well for moderate agent counts. The default agent parameter ensures deterministic behavior during initialization. Let's break it down.
From LangGraph, swarm import add active agent router.
Imports the Add Active Agent Router function from the LangGraph swarm module, which adds a router for the currently active agent to a state graph.
StateGraph swarm state.
Creates a state graph instance that uses swarm state as its shared state schema. This initializes a graph structure where nodes will communicate by reading and writing to a swarm state object, but doesn't yet define any nodes or edges. The graph is in a builder state and requires compilation before execution.
Add node Alice, call Alice destinations equals Bob.
Adds a node named Alice to the state graph that executes the callAlice function and routes its output to the Bob node. The destinations parameter explicitly specifies that after Alice completes, control flows to Bob in the graph execution sequence.
Add node Bob, call Bob destinations equals Alice.
Adds a node named Bob to the state graph that executes the callBob function and routes its output to the Alice node. The destinations parameter specifies that after Bob completes execution, control flows to Alice in the graph workflow.
Workflow equals add active agent router.
Calls the Add Active Agent Router function and assigns its return value to a variable named workflow. The function adds a router to the currently active agent in a state graph, and the resulting workflow object is stored for later use.
Builder equals workflow.
Assigns the workflow object to the variable builder. This establishes builder as a reference to the workflow instance, allowing subsequent operations to be performed on it through this identifier. The line itself doesn't modify or execute the workflow. It simply creates an alias for the existing workflow object.
Route to equals Alice, Bob.
Assigns a list containing the strings Alice and Bob to a variable named route2. This creates a sequence where Alice is the first element and Bobby is the second element, likely representing routing destinations or targets in the context of the state graph.
Default active agent equals Alice.
Sets the default active agent identifier to Alice in the current context. This assignment establishes Alice as the initial agent that will handle operations unless explicitly overridden elsewhere in the code.
Hash compile the workflow. App equals workflow compile.
Compiles the StateGraph workflow into an executable graph object. The resulting app variable holds a compiled StateGraph that implements the runnable interface, enabling methods like invoke, stream, and async execution. This is the required step to transform the builder pattern StateGraph into an operational workflow. This implementation showcases LangGraph's state-driven orchestration for multi-agent swarms, where the StateGraph serves as the backbone for dynamic agent routing through shared state communication. The pattern establishes a bidirectional workflow between Alice and Bob, with each agent's output explicitly routed to the other via the destinations parameter. The critical innovation comes from the addActiveAgent router, which injects stateful awareness by tracking the last active agent, enabling intelligent transitions while maintaining context across interactions. The configuration demonstrates a deliberate design choice, using explicit routing between nodes while delegating active agent management to the router. This separation of concerns keeps the node definitions simple while centralizing control flow logic. Setting Alice as the default active agent ensures deterministic initialization, and the compilation step transforms the builder pattern into an executable workflow with standard runnable interface methods. The trade-off here balances explicit routing control with potential complexity in larger swarms, though the pattern scales effectively for moderate agent counts by leveraging shared state and reducer functions for state aggregation.
The router points Alice to Bob and Bob to Alice, but never points to itself.